I'm Matt Dwyer with the David Ricketts Lab at North Carolina State University. Today, I want to give a brief overview of one of the classes we've developed within the Ricketts Lab, the Rabbit Radar class. In this class, students and professionals can design, simulate, and fabricate a full radar system in under a day. Not only is this radar system robust, it is also relatively cheap. We'll go over an overview of the radar system, then go into the lab to see some of the parts students fabricate during the class. Finally, we'll come back to wrap up. This will be a brief overview of our radar system. As you can see, here is our radar system. It creates an RF signal that we transmit out. We transmit that until it hits a metallic target, seen here. When it hits the metallic target, it scatters RF energy in all directions. We then receive a small portion of that scattered RF energy. The amount of time it takes for the transmitted signal to reach the target, and then from the target back to our radar system with our receive antenna, can be calculated using some circuit components. These circuit components are developed in the class by the students. Now that we have a very brief overview, let's go in the lab and see some of the components that students get to create.
With our radar class, people can create sophisticated microwave parts used in real systems while using relatively modest resources. For example, students in the radar class build amplifiers. Take this power amplifier as an example. Students solder surface mount parts, which are relatively cheap, and then create a matching network for the input and the output of the power amplifier. Here, students not only learn about the concept of impedance matching, but also apply it to a real power amplifier. And you can see these impedance transform networks are just made with simple copper form. Further, take this branch line mixer, which compares two input frequencies. Here, one can create a relatively complex and normally rather expensive microwave component by again using copper foil traces and some simple surface mount parts. As you can see, when you assemble all the parts, you have a full radar system. We have all our parts fabricated by students, including the antennas, and a simple test board. As you can see, the whole system is powered on 9-volt batteries. Also, notice that we can read it through an audio jack, so the output signal can be read by either a cell phone or a computer.